So let's take our first example of 3/5 times 1/3. Here's another, this will be the next link for you to practice with, and you can set it up here. We can change, right? Change whatever fraction we want, and same thing. And so what's going to happen when we slide this over? Same as before, right? The other one said go. This one allows you to slide it. And again, right? 3 times 1, 5 times 3. We see this 1, 2, 3 out of how many total? 15. You're like, okay, that makes sense. I can see that. And we can change that. Maybe you want to try 4/5. Maybe you want to try 6 or 7/8, right? It's going to be the same. And now we can see how, right, we're cutting the thirds into 8 equal pieces, or cutting the eighths, right, into 3 equal pieces. And that's how we get this 8 times 3 in the denominator, right? 8 times 3 is 24. And then here we want 7 times 1, right? We only want these 7 here. Maybe we wanted 2/3. Oh, now we have 14. If we, again, split this into even more, maybe we want 4/5, right? 8 times 5, we see 40 whole pieces here. And we want 1, 2, 3, 4 here, and then 7 across, right? A 4 by 7 overlap is what we're seeing here. And you can click the solution and you can simplify it if you'd like. But this is what's happening here. But what I want to show next is using this representation. Here again, we have the sliders. And if you noticed in our slides, it talks about subdivided and then not subdivided. And so I want to explain, like, what does that even mean? So we had our example of 3/5 times 1/3. And now I want you to watch carefully, and I'll scoot this down a little bit, as what's going to happen here, right? Before, we saw the rectangles just overlap with each other, and that overlap space was this idea of, right, 1/3 of 3/5, or 3/5, right? Take 1/3, cut it into 5 equal parts, and we want 3 of them, right? That's literally what we're asking for. 3/5 of 1/3. We're taking our 1/3 part and taking only 3/5 of that. So, but maybe you're also thinking like, oh, well, I know, right, this trick. And so it should be 1/5 should be my answer, right? Or which was the same as we saw, right? 3/15, my product. And so how are we going to show? We didn't see that in the last representation. How might we be able to see that here? So as I move this slider, it's taking my 1/3 piece. So this is 1/3, and now it morphing. And now we see, right, the overlap is now just this 1/5. Why is that, right? Or if we want to, you can go this way. This 3/5, this might be right. This 3/5 means I'm taking my 1/3 piece, I'm cutting into 5 equal pieces, and I want 3 of them. That's what you can see right here. Here's my 3/5. I'm cutting into 5 equal pieces, and I want, right, 3 of them, so I can keep going, right? It's going to show all of the equal partitions to show the 3/15. But why did this happen? Right? How does this show what's happening here, right, with this dividing out? And so another way I want you to think about this is, if we think about 3/5 times 1/3, right? This says I want 1/3 of my 3/5. And so if I come back here, right, here I have 1/5, 2/5, 3/5, right? I just want 1/3 of them. So I just need one of these, right? We can think of this as 3/5 divided by 3. And maybe that actually doesn't help, but if you think about this, it's kind of like redefining a whole, right? This would be what the part we're looking for, just the blue. And now I want to put them into 3 equal groups. 1 group, 2 group, 3 groups. So my product, right, 1/3 of these 3/5 is just one of these fifths. Okay, but what if we had 2/3? Then how does this change it, right? When we talked about, what's going on? Can't move this. Here we go. How does this change now, this multiplication? I know that you're right. You know the shortcut of we're going to divide out. We're not going to cancel. 3 divided by 3 is 1. And then so we're left with, we can rearrange this. 3 divided by 3 times 2 divided by 5. 3 divided by 3 is 1, the multiplicative identity. And so we're left with 2/5. Again, or you can multiply across the top. 3 times 2 is 6. 5 times 3 is 15, and get those 6/15. But so what do you think is going to happen? When we did 1/3 of these 3/5, it was 1/5. So what's 2/3 going to be? Yeah, right? We want 2 of these 1, right? It's already cut into 3 equal pieces. And right, that's what the denominator tells us, right? Cut it in 3 equal pieces. Once it's already cut in there, our numerator tells us how many we want. We want 2 of them. And so we can see that happening, right? There we go. That's that overlap right there. So that's what the slides mean when it talks about not having to subdivide, right? If one of the denominators is a factor of one of the numerators, then we don't need to make any further subdivisions. Here we had 3 pieces. Oops. We had 3 pieces, right? And we wanted to cut it into 3 pieces. So it was already cut into those 3 equal pieces for us. So what if we had 8/10 times 1/4? Again, we can think about it as 8/10 of 1/4. So we're going to take our 1/4 piece, cut into 10 equal pieces, and we want 8 of them, or vice versa. We take our 8/10, we cut that into 4 equal pieces, and then we want only 1 of them. So this is, again, this procedure, this step, right? This would be 2 and this would be 1, 4 divided by 4. And so we can see that if we cut this into 4 equal pieces, 1, 2, 1, 2, 3, 4, then we only want, how many fourths do we want? We want 1/4. And then so when we compare now this shaded, blackened piece to the whole, we're going to get 2 out of 10, right? The black is 2 out of these 10. If that didn't really make a lot of sense, we can see that happening here. We're going to take this and we're going to, right? We don't need to cut it up anymore. You can go all the way, right, to create 40ths, but you don't have to. You can stop right here and see we were able to take this numerator 8, cut it into 4 equal pieces, right? This numerator, cut it into 4 equal pieces because that's what this means in the denominator. And then it tells us how many pieces of that do we want, right? Once we cut into 4 equal pieces, we only need 1 of them. And so that's right here. And so these are your 2 out of 10, 2/10. So I want you to do some of the others, see what, continue to use either this tool or other tools and connect, again, the representations to the procedures of the steps. Why does it work that way?